So you graphed each of these on your graphing calculator. And there's the equations, and you can see them. And then I asked you also to label some points on the graph. Do you remember making a table of values last year for linear equations? You get to choose an x value. For example, in our first equation, if I say x is 1 and I plug it into my equation, 1 squared is 1, so y is 1. So that would mean on my formula, on my graph, I have the point 1, 1. That would be 1 point on my graph. If I plug in 2 for x, what do I get? 2 squared would be 4. And so on my graph, I have the point 2, 4. An important point on all of these graphs is the bottom point, or sort of, it's called the vertex. It's sort of where the U-shape either bottoms out, or if it's flipped upside down, it's the maximum point. This one happens when x is 0, and when you plug in 0, 0 squared is 0. So this one has a vertex of 0, 0. Parabola is symmetrical. So when I have 1, 1, I also have negative 1, 1. And when I have 2, 4, I also have negative 2, 4. Because if you plug in negative 2 squared is positive 4 as well. The second equation, we're going to find out what happens if there's a negative in front of the x squared. Because two of these equations had negatives in front of the x squared. Can you see what that does to the parabola? It flips it down. So this one has almost all the same points, except now they're flipped down. We got 1, negative 1. And we've got 2, negative 4. Over here, we have negative 2, negative 4, and negative 1, negative 1. Again, you can make a table of values. If you're unsure of the points that are on there, you can say, what happens when I plug in 1? 1 squared is 1 times a negative out front would be negative 1. Careful with order of operations. When I plug in a 1 with that negative out in front, that 1 would go in the brackets, and order of operations would say you square first and then multiply by the negative. This isn't the same as negative 1 inside the brackets squared. So one of the things we're going to learn in this unit is how to graph them, where first of all we're going to memorize this y equals x squared graph. We're going to look at some properties of it. We're going to learn some techniques, some patterns that we notice. For example, we go over 1, up 1, then over 1, up 3. The next time you're going to go over 1, up 5. So it goes 1, 3, 5, 7, odd numbers like that. Kind of similar to some of our, like for the group that did the odd jobs, you notice that you got paid $1, then $3, then $5, and $7, and when you added those up, you got an x squared graph. So those patterns come out in this as well. We're going to learn how to graph them when they're in a different form. One of the things that we can do with this, again, if we don't know what it looks like, we can always make a table of values. If you're unsure, you can just plug in a bunch of x values, get a bunch of points, and you might get an idea what the graph looks like. So for example, if you plug in 0 now, 0 squared plus 2 times 0 plus 1 gives me 1, and I have that point 0, 1. If I plug in negative 1, this will be negative 1 squared will be positive 1 minus 2 plus 1. I get negative 1, 0. And if I plug in negative 2, all of a sudden I get the same value again. So one of the things that we can put on a graph, sometimes we add a dotted line in the middle of it. It's called the axis of symmetry. Vertical lines, you remember from last year, always labeled x equals. This is x equals -1. And as soon as you find out where your axis is symmetry, if you know a point on one side, you know the point on the other side. So for example, another point, if I plug in 1 here, I'm going to get 1, 4. Because my axis of symmetry is there, I would know over here that I also have -3, 4, without even having to plug that into my equation. This last one, plugging in some values into a table of values, x and y. If you plug in 0 for x, you get 0. So we have this point 0, 0. If I plug in 1 for x, I'm going to get 1. So I have 1, 1, and when I plug in 2 for x, I get 0 again. So we can see an axis of symmetry down the middle, and it makes sense that we also have this point at 2, 0. So you notice in the first one how you went over 1, up 1, over 1, up 3, over 1, up 5. That happens in the second one. Over 1, down 1, over 1, down 3. If you wanted to find the next one, you could over 1, down 5. It happens in the third one. Over 1, up 1, over 1, up 3. If you wanted to find the next point, it would be up here at 2, because if I went up 5 from 4, I'd get 2, 9. Of course, you can check that by plugging in 2. 2 squared is 4, plus 2 times 2 is 4, plus 1 makes 9. And sure enough, it happened in the third one as well. Over 1, down 1, over 1, down 3, over 1, down 5, and then 7, and so on. So that's one of the patterns that's going to help us graph it. In order to know that, we need to know where our vertex is, because that's a starting point. So the x squared graph is your basic one. That's the one that starts right at 0, 0. But what happens over here? How did I figure out where that vertex was on that one? What are some of the strategies we can do over here? Now, one of the things we can do is we can find our x-intercepts. So these are all techniques that we'll develop over the whole unit, but this is just introducing you some things that you've already done. The third one there, y equals x squared plus 2x plus 1. You could factor that. It's x plus 1 squared. Do you remember how to find an x-intercept from lines? What did you do to find an x-intercept? You made y 0. That's excellent. That should be, when someone says find an x-intercept, your body should just like automatically say make y 0. Just like when they say find a y-intercept, you should automatically say make x 0. Now when I make y 0, in this case, what do I have? I have a question from chapter 3. That's a quadratic equation. And we've already learned 3 techniques for solving that. You could square root both sides, and then you would just have x plus 1 equals 0. Move the 1 over, and look at that. You found out -1 is the one that makes your x-intercept. And that shows up right here on our graph. If I wanted to find x-intercepts for the last one, can you factor that? Yes, there's a common factor of, you can factor out an x, leaving you with minus x plus 2. What makes x equal to 0? 0. So we have this x-intercept. What makes negative x plus 2 equal to 0? Positive 2. So we have this x-intercept. So that also can help us find some points on our graph. What can you tell me about the discriminant of this one, the last one? Since there's 2 roots, there's 2 x-intercepts, we would know the discriminant is positive. So all these connections from chapter 3 come into chapter 4, but now we're graphing the whole equation. So some things to highlight on our next page. I'm putting this up, yep.
Like even the sample and stuff?
Yep. We call it, instead of a quadratic equation, Now we have a quadratic function. A quadratic equation is when you had an equal sign and there was just x's with an x squared. A quadratic function has a y equals x squared. So you can highlight this whole box that we have. The general form is when you have y equals ax squared plus bx plus c. The name of this U-shaped graph that we have is called a parabola. The highest or lowest point is called the vertex, and it might be a minimum point or a maximum point. Like we said before, you can draw a dotted line to represent the axis of symmetry. And it always goes through the vertex, because a parabola is symmetrical about that line. So here's our axis of symmetry. Here's our vertex where it's a minimum. Here's our vertex where it's a maximum. And one of the things you already noticed that when the coefficient in front of the x squared is a positive number, your parabola opens up. But when you had a negative in front of the x squared, it opens down. We're going to find out that the domain of a quadratic function is everything. So we always write the domain is XER. But the range depends on the vertex. So for example, if this vertex here looks like it's at 1, 2, maybe 3, 1, does that look kind of right? Maybe 3, 1. Then the range of this one, again, your range is your y values. The range for this one would be y is bigger than or equal to 1, would be one way that you could write it. Or you could write it in interval notation, that it starts at 1 and goes to infinity. Have you seen both interval notation and set notation? Okay. This is shorthand set notation. Proper set notation would have a squiggly bracket, all y such that y is greater than or equal to 1, where y is a real number. That's the long way of writing it. Have you seen the long way? No? Okay. So the range depends on your vertex.